Awesome. Hey, everyone. Thank you for joining me. This is the 83, if I'm counting correct, meetup, February 10th. It's actually, that would be 7 years. So this is 7 years exactly. I started March 2019. This is 7 years. And we missed one time. We missed so when COVID started, was March 2020. I was doing in person. In the I used to work in a startup in Sorrento Valley. Actually, it was a more Miramar Road, and so we had like a room, and we had like 12 people that showed up, and I thought that the whole COVID would be just few days or few weeks. So I said, okay, I'll cancel that because I never did any virtual. I actually I didn't do any recording initially, and so I skipped March 2020, and then on April I resumed, but it was virtual, and since then it's virtual. We do have an in-person meeting planned for next month. If you are local in San Diego, Qualcomm building is hosting us. So there is a building on Lask Boulevard. If you're local, you know what I'm talking about. It's very close to the main headquarter, Qualcomm headquarter, and we'll have Undo company. That's the plan. Hopefully nothing happens, and we can make it. So it's all lined up, and it's all kind of ready to go, and I'll have the announcement soon. So that's the plan for next month. So just FYI. Okay. If you're new to the meetup, we meet every month, usually Tuesday. We bring all kinds of speakers. If we don't have any external speakers, it's either someone from the group or someone or myself. So there are all kinds of variety of topics. Thank you for joining. A few things that I would like to announce. That's just how to find me. This is not the Discord meeting. I have the updated one. I'm just not updating the slides, but I have an updated Discord link in the chat. So please pick it up. 1 second. Let's see. Okay. And that's basically what we have. JetBrains is sponsoring San Diego C Meetup, and JetBrains are actually paying the meetup dues, which are about $300. Not about, it's exactly $300 annually. And I'll talk about it in a second. So I don't know if Packet has still discount for this book. This is actually a nice book. There's a lot of good chapters there. Try CPP 20 for the ebook. But the interesting part is that there is one chapter in this book that gave me the idea of this specific session. Okay, announcement. I am done with Meetup. I fed up. I'm not gonna pay another 300 and ask for sponsorship and all of that, and I'm not gonna ask money from people attending the Meetup. So I decided to leave meetup.com. So I'm gonna step down as the Meetup organizer within a couple weeks. So I have another 2 weeks to the next like cycle, annual cycle, and I'm gonna leave Meetup. I'm gonna do all the announcement. We're moving to luma.com. It looks pretty lean, and I like it. So if you just Google San Diego C Meetup on Luma with luma.com, you'll get the calendar. So calendar is equivalent to a meetup.com group. So that's what's gonna happen next time. So make sure that you are tuned to that. There's also the Discord link. You can find me online, Gmail, LinkedIn, whatever works for you. Please reach out if you need anything. Okay, this is the agenda, the original agenda, but we're gonna skip one and we're not gonna do three. Reason is that I have some hard stop in 30 minutes, so we're only gonna do the second one, which is basically the beef. Some miscommunication with my wife. I should have known that there is some prior engagement that I missed. So we're gonna skip the CPP quiz and go directly to the main talk for today, which should take about 30 minutes. So I actually so let me tell you the context and how I ended up with this talk. And by the way, if you're new and you would like to have a talk here and all, this is an example of how a simple thing led to 10, 12 slides or more. And it's interesting. So what happened is that I was reading this book that I mentioned, this C++ architecture, which is basically the second edition. It's a pretty thick book. Actually, it sits next to me here. And there was one thing that I wanted clarification. And today, when I need clarification, I'm not going to Stack Overflow. I'm not Googling. I basically go to my whatever available LLM. Sometimes it's Perplexity, sometimes it's Gemini. At work, I'm using Perplexity, Cloud Code, and I have other tools. Like in NVIDIA, we have million AI tools. So I just pick one. And at home, I have Gemini. Sorry, I need to get people in. So at home, I have Gemini 3, like paid version, and I ask Gemini, hey, I have this code snippet from the book, and just explain me X, Y, and Z. I just wanted some clarification. So Gemini goes and gives me this, oh, this is how it should be, and this is the clarification and all. And at the end, it says, by the way, this code has a UB, undefined behavior. And it was like, interesting. Okay, what do you mean? And sometimes they do hallucinate, so you need to prove yourself that um, the model, the LLM model, is actually saying something true. And this specific example, or this specific thing that LLM pointed out was seems correct. And I that's basically the highlight of this talk. And what I really like in the next few slides and the code example is that you'll be able to see a lot of very kind of latest idiomatic C++ concepts and CRTP, and I'll explain all of that. If you are new, I'll make sure to take it slow so you can digest that, and I'll publish the slides so you can take a look later and go again one by one and take a look at the code that I used. So I took the code from the book and asked the LLM to create examples for me for this talk. I said, okay, this is going to be very interesting for others to be familiar with. So that's what gave me the idea for this talk. Okay, let's start. So if you're new to C++, multi-paradigm language, like I know C++ since 1997. That's the first time I actually took a class. And what I really like in the C++, it's just multi-paradigm. There's a lot of things that you can do with that. There's a lot of techniques, and I just feel that this is a very rich language. Obviously, hard to learn and lots of lots of things to remember. 1 second, there's another guest I need to admit. Um, but there's one thing that I would like to discuss today. This is polymorphism. So there are roughly two polymorphisms. There's compile time, there's runtime polymorphism. I think a lot of people know runtime polymorphism, especially coming from Java and other languages where runtime polymorphism is something that is very basic and built into the language. C++ has not only runtime polymorphism, but also compile time polymorphism, which is basically always kind of a template related. So people might ask, like, why do I need compile time or maybe static, not runtime polymorphism? There's a lot of reasons. I'm listing few of them. vtable overhead. Vtable can be the pointer, the vtable pointer inside, and the indirection. There's a lot of things that you can take any book or today Ask LLM can tell you exactly what the overhead. Even if it's small and there's a lot of blog posts about the overhead of indirection, but static polymorphism doesn't have that. There's other stuff that you can argue, but it doesn't have the redirection. Compiler has better visibility to what exactly you're doing in terms of polymorphism. Preferred value semantic over pointers. So that's something that a lot of advanced people opt into instead of pointers. And then there is this technique named CRTP, the curiously reoccurring template pattern, which kind of enforce this whole methodology. So that's part of the book. So let's take a look at two code snippets. One of them has the UB, and the other one has it just demonstrated. So, and the next one just talk about the UB. So let's go to the first one. Is this too small for you, or is it good enough?
It's good for me with the 4K display.
Okay, I see a lot of thumbs up. You can always ask me to increase the font. I don't care. I can increase the font. Okay, so CRTP. CRTP, if you're new to C++, you're probably not seeing that a lot, but it has a lot of good application or good usage. Here's an example of using CRTP. The way to recognize, oh, this is CRTP kind of idiom or syntax is the following. You have a base class, and yeah, there is improvement in C++ 23. I'm not talking about this is C++ 20, but yeah, there is a C++ 23 that makes this a bit more nicer. But let's not talk about it for now. There's a base class that has it's a template class, and it has a function, and the function basically has this weird syntax, the definition of the function, where it's taking this, cast it to the concrete item, and call the function. So the idea is very simple. It's the following. If you have a class that inherits from this specific base class, and the template parameter is the same class, so you can see it here. And there's a lot of blog posts about what happened if you make a typo, you copy paste and you make a mistake. That's beyond the scope of this presentation. But let's say we didn't do any typo. So if you and this is the base, this part of this code would repeat towards all this code snippets. So make sure that you understand this part clearly. So this is the function that eventually, if I have an instance of pink hills and I call appear in full glory, and if I have an instance if I have a reference to glamorous items of pink heels, and I call appear in full glory, that would redirect that to this function. So just imagine that I have these pink heels. For example, if I have it here, maybe I should do something like a function. So if I have this function, second, to meet people. Okay, so if I have a function, where is it? Where am I? Okay, it's a template function. And there's a lot of ways to type name t item, and I do item dot appears glory. Okay, and I have pink heels, and I call f with pink heels. This looks polymorphism, right? I have a base class, a reference to a base class, and I call pink heels. I have a concrete class, okay, and I call this. So what happened is that this call, this one that I'm highlighting, goes through here, and the compiler has full visibility of what's happening, and it's casted down to the pink heels one, to this guy, and this is what is gonna be printed. Okay, so if I didn't make any mistake, this should be printed here. Okay, so okay, so this is basically CRTP. So I have two realization of this CRTP. I have pink heels and golden watch. By the way, not that the class names are completely from the book as far as I remember. It's like I didn't make up these strange names. Okay, now the trap. The trap is the following, and we'll see a few examples here. There is a stu tuple, a variadic template that takes glamorous items args, which means that I can have multiple of them, right? So imagine I have this guy versus items, and I put multiple. I have two right now, and I'm instantiating. The issue here is, and this is what LLM figured out. And by the way, I posted a report to the author, which I haven't received anything back yet. But what happened here is that the slicing happens here, which is this subtle issue here. The derived part is sliced off, and we only store the base. And this is an undefined behavior because we're actually casting that to the derived, but there is no derived. It was sliced. So slicing is a very basic C++ 9803 terminology. Like, this is very ancient. Slicing means I have hierarchy of classes, and in a polymorphic mind, I'm thinking that, oh, I'm holding a base, but actually pointing to a derived. But by accidentally doing slicing, I'm actually holding a base, period. I'm not holding a derived. What happened is that with a mistake in the syntax, this is where C++ is kind of difficult. You can make a mistake in the way you write your program, and you pass a derived to a base class, and only the base class part of the derived is copied. Okay, so you're holding only the base class. This is actually what happened here. So I have a stu tuple. Think about this. Here, it's stu tuple is like pair because there are only two. I have items. Okay, so I have items, and I'm calling each. So stu apply takes these items and apply this take it's like it's unpacking them here, and I can it's just a trick to take multiple items in tuple or tuple, I don't know, right? But like what's the right, and you just pass it here, and this is like a very old technique to have these functions invoked in multiple, like in one expression. Now, if you see it first time, this is like C++ 11 niche trick. If you see it first time, it looks very cryptic, but it's just because maybe the dot 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 is like the variadic template is kind of new. This is might be new. This is the C++ 14 feature. But basically what happened is that I have a stud tuple that I think I have pink hills, which I don't. I have actually glamorous items. I'm losing the pink hills. I'm losing the derived, and I'm calling the function that is doing the cast, and this is the UB. Okay, so you can't see that there is a UB because this pink hills has no members, right? So the size of it's probably 1. It's like there's some optimization here. It's not, there is nothing special that would trigger, like to show you the UB. There is a UB, but it's hard to show that. So if I just run the function, run the program, I can see that these two are being printed. So you might say there is no UB, but there is a UB. Let me show you. Same code, but I'm adding member, and I'm printing the members. And I'm not doing anything different. Well, I have a variant here, but it doesn't really matter. It's the same deal. Just to show you another option, but it's gonna do the same thing with the stud tuple. And I'm using stud visit, but it's the same thing. It's the same thing in the sense that the item is being sliced here. Okay, so if I run it, you expect 42 and 999.99, but when it's printed, and this is where it's printed for each item, this is the stud visit part, which has the for loop. You can see 0 and 0, which means that this is a UB, which means that this value is gone when this is invoked, and this static cast to the derived is gone. Why? Because we have this slicing happen here, and it's kind of the same as what happened here. I'm just showing you another option that the book shows. How do you think we can fix that one here? I gave you a hint before. This is sliced because it's taking by value. What do you think we should do in order to fix that? So one character change.
Pass by reference.
Reference. Let's try it. So when we do reference, we're basically not passing a copy. So when you don't have reference, there is a copy happening. The copy just take the base values because I'm slicing it. Just remember that slicing means I'm losing the derived. So every derived class has a base class and derived class part, right? If you have members in the derived class, this is easier to show how the derived is sliced, and only the base part is left. So whoever said reference means that we're not making any copies. We're taking the reference and using it as is. This is where we can see that everything looks fine. Okay, let's go back to the slides. This is the trap. The stud tuple, when we write stud tuple glamorous items, you can think that this is fine because it's a base class of R with the args, but that's not correct. There is a slicing happening at the time of defining the tuple. And this is the confusing part, at least confused me, and I learned that while looking at it. When you slice it and you try to static cast to the derived, so concrete is the derived type, this is an undefined behavior. The CRTP pattern relies on the fact that the full derived object exists. If you have slicing, you just left with a base object. Trying to cast this to something which you are not is a UB, which makes sense. Okay, so let's take a look at what I should do. Let me just close everything here. It's easier for me to navigate. Okay. So this is what I showed you before, where we have stud variant. It's just another version of how you can iterate over the elements. There was one version where we did stud apply. Stud visit is another way of taking a variant. Okay, item is a variant. Globus items is just an array of this stud variant. Variant is basically, you can think about if you're new to C++ 17, this library was introduced in 17. You can think about variant like an interesting union. Okay, so I have either this guy or this guy. 1 second. So I have an array of these two. I'm taking this array and I'm iterating over the array using C++ 11 range for loop. Okay, and stud visit allows me to take the element. So if you look at stud visit, it looks confusing, but there's basically two arguments that I'm passing. One argument is a function, and this is C++20. It's a lambda, it's a templated lambda, and the second argument is the stud variant. It's the stud variant. We have two in the array, and this is where we had the UB I mentioned. So the pink hills is sliced, and then the golden watch is also sliced. So this is where things get into a UB state. Okay, now let's show you another option of writing the same thing, but in a more advanced fashion. Having a kind of a wrapper approach is, I'm going to discuss all these 4 or 5 bullet points. Okay. Everything stays the same. This is the base class CRTP. I haven't changed anything here. This is the first derived pink hills. I haven't changed anything. It's the same type. Same deal with this with the second golden watch. I haven't changed anything. Stud variant. Again, if you're new to stud variant, you don't know what it is. Think about it like I have a union, and then I have either pink hills or golden watch, and I can instantiate one or the other, and I can have multiple stud variants. Stud variant is a template typecast that I can have multiple of. I have only 2 here, but I can have multiple. Okay, now I have a wrapper. The idea behind this wrapper is that I'm hiding that stud visit that used to be in main. I'm hiding it in a wrapper class. And the nice thing about this example, what I like about this example is, so this is the same thing as I showed you last snippet of code. Nothing different. It's a function with the stud visit that takes an item, which is a member here, and just invoke the stud visit on this item. And this item is a variant, so it can be either pink hills or golden watch. So this one, very, very simple. What I like about this example is the opportunity to show you C++ 20. 1 second, someone is asking something? Yeah, yeah. When I say union, don't take it literally, please. So take a look at the uh, union is like that's the only way I can explain quickly what is variant because people know what's union. But it's someone said it's a tag. It's like a tagged union. There is the type. Yes, it's not union in the sense that it's not implemented as a union, but it's much more. Just the easiest way for me to explain. Okay, going back to here. This is an opportunity for me to show you C++ 20 concepts, like how you can actually utilize C++ concept. So I have a constructor. This is just a wrapper class. And it's taken from the book because they want to show a wrapper class where they push the stud visit inside a function that hides this ugliness behind a function. And we'll see that main becomes very, very clear. So that's what they wanted to show. But what I really liked is the opportunity to show you how we can constrain the construction of this wrapper class. So I accept only T that inherits from glamorous item T. So I can accept pink hills. I can accept golden watch. If you try to instantiate this wrapper class with a stud string, you'll get a nice compiler error which says you cannot do that because this is the constraints. This is because I have this constraint. These constraints are, it's basically C++ concept, and it says the following: T, which is the template parameter of the constructor, it's only on the constructor, it's not on the class, requires that this one is the base class of this one. So T, and here that's you remove constants, volatile, reference, just strip everything from T. Same here, same deal here. It's just boilerplate code. But think about T inherits from glamorous items P. Only in this case I can instantiate this wrapper. And if you don't know what stood forward, doesn't really matter. It's just a way for us to get this variant instantiated in a efficient way. Just remember that. That's enough. And I have the same array, 2 items. Stud array is basically a C array. And I'm iterating over that. This time, I'm hiding this stud visit that used to be inside the main. I'm hiding behind this wrapper class. And you'll see that it's going, like if I generate with O3, it should, yeah, what did I do wrong here? There's some typo here. Okay, so if I need to compare this one with the non-wrapper, it's going to be the same. We have a UB because we still have the slicing. This is slicing, as someone said before, we can fix that by having a reference. This is not a slicing. This is, by the way, the most important part of the talk. Like, be aware of slicing. It's very common to see that in code if you're not careful enough. Hopefully LLM are not doing this. Okay. So this is what I was talking about, this wrapper class. Okay, how do we fix that? So I showed one option. There are more options. Okay. Few options. This is the same. Nothing changed. CRTP base class with 2 derived class. Here, you can see that I have stud tuple of not glamorous item something, but I actually have the conflict types here. And there is no slicing here because I have the exact type here and not the base class and then in angle brackets the pink hills. No, I actually have the concrete class, which at the instantiation time, this is the type that is uh, that sits in the tuple. So you can see that we are good. We have the right size, and we have this printout. So that's one way. I wanted to show another way. Uh, you can still have the stud tuple this way and instantiate this with this option. So the instead of stud tuple, you can have a name of precious item. It's just a type def. It's just to make the code more readable in the sense of instead of having stud tuple of pink heels and golden watch, I create this small type def that I can have. Okay, these are precious item. Here are the two things that I have inside, and this is not a UB. Again, because I'm using the exact types that I have. I don't have I cannot prove that here, but it's that it is what it is. What we do enforce here is a static assert that that pink hills is base off and so on and so forth. Just manual check. This is a stud apply that I showed in the first snippet of code. What do you think we can do better here? That's like another option. So I was like, when I was reading that, this is not part of the book, I think. This is already beyond that. But I was thinking, can we have C++ 20 concept slapped on top of that? And the answer is yes. So I'm defining a concept, which is very similar to what we had before for the constructor of the wrapper item. T is based off, is derived, sorry, it's derived from glamorous item T. And instead of having, so take a look at this syntax. This is a C++ 20 syntax. This is not pre-20. Because pre-20, I have a type def here. Sorry, a type name here of this type def. And here, what I can put, I can constrain my template arguments to be only these. If I'm trying to do, okay, so this is gonna work, right? Okay, and let's try to do two. I don't know what's going on. I'm trying to write something and it's not giving me. Okay. It's like I have control sticky. Huh. Yeah, it's like I have a control. Let me just reset my keyboard. I don't know what happened here. Okay. Yeah, I have like a control or something that, and I have no idea what happened. I know what happened here. I'm trying to put stud string here. Okay, let me try to unshare and share it again. I want to show you that. Yeah, it's something with the Okay, so what I'm going to do, I'm sorry about it. This is not, yeah, it's not solved. It's like I have a control key stuck, which, okay, so I'm gonna just exit the whole thing. Sorry about it. 1 second. Let me see if I can fix it quickly. Okay. Let me see. Okay. No, it just doesn't work. I know. I have no idea. It's like something with the Java. I don't know if the JavaScript is busted on Godbolt. Uh, it just, what happened is that I always have this. Yeah, I can't really type. uh, super interesting. It's only on Goldbolt, so I don't know if they did something. Okay, let me share. I just put I opened Notebook and wrote std string to to do that. Uh, is it this one?
You're muted.
I'm muted. I have a hard stop, by the way, and I need 2 minutes. And my Linux crashed, like not the entire thing. The UI session manager just crashed. Like I saw a kernel message and it restarted the whole. So yeah, okay. Let me try again. I'm moving to Windows. That's it. I know.
That's a big mistake.
I,
I just
I
tried it like an hour ago, and it just like wants me to back up everything.
it's like you need to hit like something with the drivers is just not like, I don't know. It's a long story. I'm not gonna. I might need just a new computer and that's it. Okay, let me see if I can share something. And no, Windows. People don't want me to leave Linux. I'm doing Linux for 30 years. Like I used to compile my modem in order to have. Okay, let me see. Okay. Okay, so I do have a std string here, and you can see that if I put std string, I have an error that I cannot have this std string. So that's what I wanted to show you. That's it, and we are pretty much done. So this is just summarizing what happened. This is the slicing problem. Std tuple of glamorous items, pink hills. You can see that this is the slicing part. Okay, I show you that. Can I do this? Can I have reference? So I said, okay, let's have reference. What happens when you say when you have reference? So I wanted to demonstrate that. This could work, but it's not going to work. Actually, it's not going to work. Why? Because when you have pink hills and you have reference to this, it dies right there. So you're going to have a dangling pointer. So you cannot have std tuple of this. The only way to get away with it is to have std tuple of the actual derived type. And this is the whole summary. Hopefully it's still recording. By the way, I don't know if it's still recording. It is recording. Yeah, that's what I had for today. Hopefully squeezing a lot of information and a lot of small C++ related goodies. So we looked at concept, we looked at CRTP, we looked at std visit, std apply, tuple, variadic templates, static assert, range for loop, UBs. That's it. That's whole C++. You know C++. You are certified C++ developers just by knowing all of that. And we know slicing, which is the important part. Any questions? Sorry about the technical issues. I need a new computer. We all agree. I'm taking the $300 that I'm saving on Meetup and buying a new computer. Only the memory is like $10,000. So go figure. Yeah, it's all this AI bubble, which I'm fueling by using it. By the way, I keep thinking about having an AI focus or centric session because I'm using it so much, and I think it's a science fiction. I would like to have a session where people argue with me because I have so much. So I started that in February last year with Cursor and then Cloud Code, and I did some JetBrain and science fiction. Sorry about it. We are all doomed, by the way. If I didn't mention that, we are all doomed. So hope everyone have a plan B, because we need a plan B. Why as memory? Because this company went off consumer and is only selling that to data centers. Slicing as in base class. Okay, so people bumbering with questions. Okay, let me read. Okay, okay. Yeah, tref, someone mentioned. I don't know what was the context. And then Windows versus Linux. We're not going into that. No. Rust does not allow inheritance. Rust doesn't have inheritance. They have traits, which I basically I really like. And when I write C++ polymorphism, I have few rules. One is very, very, very shallow inheritance, like base class, and it's pure. And the only exception is mixin. So I'm using mixin if I want to do some code boilerplate removal. So mixin is one of the things that I'm using. So slicing in C++ related to Rust slice. No, Rust slice is something else. It's not related to inheritance slicing in Rust. Rust slice is something else. It's like a range. Yeah, views. So someone said views. Yes, views. It's like a range. It's like a non-owning view. Um, any other questions? It was fun, by the way, and hopefully I can see you in person next month in one of the Qualcomm building in Sorrento. Yeah, if you don't have any other questions, we can wrap it up. Oh my, yeah, I'll be in trouble if I'm not wrapping up now. Okay, folks. Thanks everyone. Have a good rest of your day and week. Ping me offline or online when you if you have anything you would like to discuss. Take care. Bye bye.
Great. Thanks.